Edition of 3D Printing News Unpeeled. And yeah, welcome. So we've got a couple of news items today for you for us to look at, and one of them is the first one is well, I think it's a really exciting thing. It's Fun 3D is association of 3D printing companies in Belgium and the Netherlands. And what they have done is they've 3D printed a large part of their Formnext stand. So they have a 24 square meter stand. And what they're doing is they're making 130 different 3D printed parts using 15 different 3D printing technologies. And then they're complementing these parts with just like standard manufactured parts to create a 3D printing stand that's made out of 3D printed materials in part. And that showcases all the materials that, or the parts that the constituent members of Fun 3D make. So all these parts come from 15 different technologies from all the different members of the Fun 3D organization. So I think it's a really cute idea, first of all. Secondly, this idea of combining these 3D printed customized connectors with standard extruded rails or other kind of like really cheap materials is a very, very powerful thing, I think. It's a very, very powerful, potentially very exciting application. I mean, Halle-Wittenberg, like a design company, showcased this many years ago. There's also firms working on trying to make these customized parts for facade elements. So have a standard facade element, and then in order to get lots of different geometries and lots of different shapes that find on facade of a building, they're making 3D printed connectors that have really specific geometry. So as an idea, this could be a very good one to making temporary structures, to making structures that are like tents or tent-like, or think of things like greenhouses, for example. A really great idea to use 3D printing for specific small geometries and to use standardized production technologies to make that structure really large. So I like that combination of both of those technologies, kind of like getting the best of both worlds. And on top of that, think about the stand business. Think about this exhibition business. All these people making large logos, large stands, large kind of cupolas and other kind of things. This could really be an application that could be very, not a breakthrough for them, but it could really augment their services and augment what they're making already. So really like this example by Fun3D for Formnext. The next thing we have is, well, it's a 3D printed ring, or, well, any other kind of thing you want to make. Essentially, it's a 3D printed mosquito repellent. So what FanFan do, along with, we're working together under the supervision of Professor René Androsch at the Martin Luther University of Halle-Wittenberg. What they did is they wrote a paper for the International Journal of Pharmaceutics, and they encapsulated a mosquito repellent inside of a ring in this case. And then 3D printed that ring. So think about, like, for example, having customized rings that are super comfortable, or bracelets that are really comfortable, or think about a 3D printed thing that fits onto your smartphone, or that's a part of, a part of your backpack or something like that. Or think of a custom thing that fits on your helmet if you're cycling that you can customize. There's a lot of options here. What also is, I think, one reason why this should be looked at by a lot more pharmaceutical companies for a lot of different things is that, well, they're using a standard material. It's called IR3535. It's an insect repellent that Merck brought onto the market at one point, and it's really standard as a spray. Now we can then, through making this custom geometry, not only make it custom fit the person or custom fit a particular application, think of something for your cycling glove or whatever, but what we can also do is change the release kinetics through changing this form, or changing the porosity of this form through making gaps in it, things like that. Now, in a very advanced kind of stage, imagine, for example, you could, every time that the body temperature cools down, you could have the pores open up a little bit more so that they would release more insect repellents. The idea being that if at dusk, for example, or if you're sleeping, maybe the mosquitoes really latch onto you. Whereas if you're warm, it's the middle of the day, maybe they don't. For example, I don't know if that's true, but just an example. Then you could make a form that's optimized to even release this repellent in a higher, a higher like rate. When the conditions are optimal for mosquitoes. So I think this is something that a lot of people should look at. And what I love about this is that we're not changing the substance. We're not having to go to regulators and say, hey, you know what? We need this really super cool mosquito repellent. We're saying, no, this is something you've approved decades ago. This is something that already exists and has been used for so many years. we just want to encapsulate it in this different form. So I think this is something that really is very commercializable. This could really lead to a really array of commercial products that wouldn't get this sticky substance. It wouldn't need you to apply it on the skin, but you could just have it as think about it as an earring, a mosquito earring, or wouldn't be that bad, the earring, or a bangle on your necklace or something like that. The ways you can apply this are legion. So I love this. But still, the top news is that KnaussMaffei has joined the 3D printing business. So KnaussMaffei is maybe not a really well-known company. It's a $1 billion publicly traded subsidiary of China National Chemical Corp, or ChemChina. It has $1 billion in revenue in and of itself, so KnaussMaffei itself, and it gets that revenue from making polymer and processing machines. So it makes like extruders, but giant extruders, like basketball court filling extruders, and even bigger, that make like thousands of tons of material an hour. They make like industrial quantities of polymer, right? That's into filament and mixed together using their equipment, their twin screw type equipment, or they make things like really large injection molding equipment. So they are one of the most knowledgeable companies on earth in terms of plastics processing. They also have a very mature, very long-lasting dealer network. The company itself was founded in 1838, and they have a very mature dealer network that has its own direct sales network that deals with some of the largest companies in the world. If you are a really large company and you want to make a really injection molding machine that is like the biggest and lasts the longest, you're definitely going to talk to KnaussMaffei. So these guys are like, the network they have of really large manufacturers is almost, I wouldn't say unprecedented, but it's very, very strong. Now, these guys are now releasing 2 3D printers. Now, we've had a kind of our flirtation with a bunch of large companies that come to our market and then end up not doing much. I think this may be a bit different. First off, KnaussMaffei's core business is polymer processing. For them to take an interest in this, they must know that something is going on, and they must have some market knowledge, right? And they have core knowledge in this polymer processing segment, right? Especially on the power print. So they have 2 machines. One is, I think, a little bit further away from what they do normally, and the power print is very close to what they do. The power print is a large-scale material extrusion machine that has nozzle choices between 2 millimeters and 20 millimeters, and you can get an output of 0 to 10 kilograms an hour, or with the different setups, you get up to 30 kilograms an hour of material extrusion. Now, what's more is they could do this the nozzle temperature up to 400 C. So that means 400 Celsius means you can process a lot of materials, such as polyamides, for example. There's a closed chamber with a chamber temperature of 60 C as well, a vacuum print bed, which is very, very handy. What is one thing I think is really new, as in, like, everyone kind of has 3D printers that open up in the front, right? Because that's what most of them do. What they have is they have a kind of an accordion-based kind of 3D printer kind of enclosure from the top, right? Very similar to some of the accordion-based things we've seen on some other printer manufacturers, but this is that enclosure can completely be removed, right? Because this accordion thing like encompasses the motion stage, the top motion stage anyway, right? It moves along with it to let heat escape. What they've done is they've let you pull back this whole curtain, and then you can put a crane in and lift off the 3D printed thing from the top and take it out. So if you're working in a really high throughput kind of way, if you keep wanting to make these things, this is a very sensible thing to do. And you could even think of like the printer maybe purging material, or maybe starting again in the corner and you lifting up this big item already. So you probably have to, of course, bring the temperature up to speed and all this again. So maybe there is a pause, but I think it's a really exciting way of making this work with a gantry system in a big plant. So I like that. The other thing I really like is that this thing makes 2 meters by 2.5 meter by 2 meter parts. So we're seeing a lot of innovation at the really large scale stuff, like a 4 or 5 meter and stuff like that. But I think there's a huge sweet spot for really large scale automotive tooling and small tools for aerospace. Like, think, for example, for automotive, like a tool, not like right now when we talk about jigs and fixtures for automotive, what usually it is, it's like a little jig that you use to make sure that the Mercedes-Benz is correctly aligned, for example, literally the nameplate of the car. Or we're looking at other things. But what Materialize did previously is to make tools for example, bumper alignment, right, with this rapid fit. I think that market worldwide, especially in the space with 2 by 2 by 2 meters and smaller, and especially if it's really dimensionally accurate, is potentially quite huge and underserved, right? There are very few companies that are really focusing on this space, and I think this is the sweet spot to be in. A lot of people are trying to get much larger than this. I think this may be a very much closer to market kind of thing. You've got Juggerbot in the States that do these kind of things, and nobody else really is doing this in a really kind of industrialized type of way. So I think this is, to me, it's a beautiful place to be in, because imagine like a really large CNC tool for measuring a car bumper to see if it's the right size, or the car hood or doors and things like that. That thing made traditionally is going to be incredibly expensive, and if you're going to print that thing, it's going to save you so much money. Now, the printer can use ABS, PA6, for example, which that must have been quite difficult for them to do, by the way. PETG, PLA, and ASA. ASA is a material I really like for outdoor applications. It makes things like, ASA is used for, or ASA is used for the mirrors of your car, for example, stuff like this. So I really like that. But there's another thing I really like, and that is this is a granulate extruder. So this is a granulate machine. So that means that your material is not going to cost $20 a kilo. It's going to cost $3 a kilo, or $6. So that really saves money. So this to me is a very credible machine. I love the idea of large scale tooling, and this being used for large scale tooling and the production of said tooling, especially if we're going to recycle the granulate out of whatever bumpers or whatever stuff they're making already, and then we make the tooling out of that. That helps these guys hit their ecological goals. Also, by putting this thing in the plant, it means they can make this tool, this really large scale tool, not only like a tenth or 20th of the prices if they do it, but also if they do it with CNC, but also they're going to be much quicker than if they outsource this. So I think this is a really great machine. Now, this is really, I think, given their network and the extent of their network and the types of companies they sell to, really large manufacturers, they should be able to shift these machines. Now, the other machine is a bit more, that's going to take a lot more work by them, unless they already have customers that are doing this. That's an SLA machine, essentially. It's a 250 by 250 by 400 dual tank SLA machine. And that, to me, is a little bit further away from what they normally do, but maybe they have customers for it as well. But this has post-processing solutions along with it. And at the same time, what it also has is it comes with software. So the machines, the fact that they have two machines and they come with software and they've thought about post-processing, to me means that this is something that's a very credible kind of thing for our industry. And this is a very credible company. It's a big company. It's a company that understands polymers and thermoplastics, that understands what is needed, that understands what manufacturers need. And they make very reliable machines so far. So if they manage to make this granular extrusion machine, this SLA machine, a very reliable, very industrialized machine for production, this could really mean a lot for our market. Thank you very much. This is another episode of the 3D Printing News Unpeeled. And enjoy your day. Thank you.